So hello all, we are live and we are starting. Welcome to our webinar session and thank you all for coming and joining us. Today we're presenting our CAN solutions technical part. So let me introduce myself. My name is Airidas. I'm a technical support engineer at Teltonika Telematics. Together with me today, project coordinator for CAN solutions, Yuri, will be joining. He will help me and assist during the Q&A session. So topics that will be covered today will provide you basic details on the concept of our CAN solution. We hope that this presentation will be informative and useful for you to start with CAN solution installations and cover any unknown points to finally accomplish your expectations by using our products. So let's begin. I will walk shortly through the agenda of this presentation. At first, we will introduce you to the CAN bus network and provide you basics on it. Afterwards, I will guide you throughout the pre-integration process. We will provide you useful tips to follow throughout the installation. Afterwards, I will describe procedures to add new vehicle as supported. Common mistakes and debug options will be also covered at the last point. And afterwards, all information is discussed. We will have a Q&A session. So let's begin in regards of CAN bus network. So for better understanding, let's define and break down the basics of this network and its application and also main properties. CAN bus uses two dedicated wires for communication. These wires are called CAN high and CAN low. As presented in the schematic, CAN controller is connected to all of the components on the network via those two wires. The electric signal differences generated in the lines are equal to logical zeros and ones, from which data messages are formed. It is all important to consider the physical layer properties of this type of network and the fact that it's used in automotive solutions where sensors and controller data must be delivered without errors. Basically, noises are generated in lines by magnetic fields, which may affect the data integrity. In straight cable, noise current is flowing in the same direction, but when the cable is twisted, in some parts of the signal lines, the direction of noise current is opposite from the current in other parts of the cable. So in such scenario, noises are many factors lower than with an ordinary straight cable. As a conclusion, we highlight this point to notify you that you will find a twisted pair representing the CAN lines where connection will be made. To further advance, most motor vehicle CAN networks operate at bus speeds of 250 kilobytes or up to 500 kilobytes. The latest vehicles use up to 3 separate CAN networks, usually of different speeds, connected together by gateways. So low-speed lines are used for nodes such as air conditioning unit, cruise control module, and other convenient modules. High-speed nodes are used for more important nodes, for transmission, suspension, ABS, and other type of modules. All control units on the bus are effectively in parallel. That's why all of the nodes see all of the data all of the time. As a result of this logic, we can monitor the signal by directly connecting with our CAN solutions. Depending on the vehicle model, it is necessary to connect CAN 1 line or both CAN 1 and CAN 2 lines, since this grants us full access to listen to the transmitted data of main parameters. Here, in the provided frame specification, you can see a regular CAN message. As visible, it consists of several fields, such as start of the frame, CAN ID, and others. However, most important field is data field. Even though different manufacturer messages follow the same CAN frame logic, and base structure of the data is identical. However, each network node has a unique identifier. Different parameter IDs may be used. There are also differences in data byte order, offset, signal count in one message, and other differences. Therefore, in order to be able to decode the data that is being sent and read the parameter values from different type of vehicle models, it is necessary to perform reverse engineering tasks. So, to simply put, we have to know how to provide human readable information from the data. As an example, from several messages following the previously provided points of knowing each byte order and offset, we can have real values which will later are saved as I/O elements and sent to the server by our units. Let's move on to the pre-integration details. So, to proceed and complete vital steps that our engineers must take, we need a direct access to the vehicle and execute tests live. So we first, of course, require to determine the CAN location. So usually CAN locations are near the OBD port, under the dashboard, or in other common locations. Afterwards, our engineers are able to determine the location of CAN lines. We execute tasks of scanning, reading the data. So when scanning of each individual vehicle is completed, we prepare a software changes. So basically we create a specific software to add a new vehicle. And also we create data reading configuration. So we call it program number. It is a specific code that is used by our units in the and is configured. All of the supported, so afterwards, all the steps mentioned are completed, and we have the program number and the software version. We confirm the vehicle as supported. All of the vehicles in the supported list are already tested and are confirmed as working. To further advance, our supported lists contain different types of information. So to help you and assist you for further analysis on each supported list, I define you the main points. So we have a solution type. So basically each of the different type of CAN adapter will have a specific supported list. Each of the lists will include specific parameters listed. The parameters that are readable for us from the specific model of the vehicle are marked with the cross. We have a list of models that are already included in the supported list, so placed here. We define the manufacturer year of that specific model, and also we assign a program number for it, and of course a minimum required software date. This information grants you the information required to identify description, what type of solutions we have and what are their main differences. We have this table. So basic parameters listed as are understandable as full level, engine RPM, speed, mileage, or door status. So these basic parameters are supported by all of our CAN solutions. More specific electric vehicle parameters are such as battery level, battery temperature, vehicle range on battery are supported by our CAN control solutions, FMB 140 with all CAN option or all CAN adapter. Additionally, there is a number of specific parameters related to trucks, buses, agricultural machinery, and special transport. So such parameters can be defined as axle loads, mowing status, PTO, and these are only available using our all-CAN solution. So FMB 140 all-CAN option or all-CAN 300. There are also functionality related features. So control related features would mount to door lock, unlock, trunk release, turn signal control, or other functions. These are supported by our CAN control adapters, so all of them. We also have ability to read DTC codes with specific units. So this feature is supported by LV-CAN 200 plus DTC or CAN control plus DTC. Additionally, and lastly, immobilization is available with our CAN control plus IMO unit. Let's move on and define steps for accurate SIM selection. So basically, if you're able to determine the make year, the model, the generation, and the options of the car, it will be useful. Considering the options of the car will be such as keyless option or not, electric vehicle or not, left-hand drive or right-hand drive, different variations of same vehicle may use separate program numbers. So here I provide you an example. We have a BMW F30. So right-hand option uses program number 12747, and it's specified in the semantics. And the left-hand drive model uses the 12746 program number. So this is noted. All of this information is noted that you must consider the options of the car because they may use different program numbers. So make sure to always double check this point. Alternative way to determine fitting semantics is to follow the VIN code. So at this part, we can shortly describe on how to determine the model and make year precisely. So basically, as a starter, if you know the vehicle VIN number, you can look in our semantics, and some of the semantics will contain information which distinctly matches the specific vehicle model. So as presented here, you will see that this schematic can be used for models starting with the specific VIN number. This means that you can make sure it will fit and you will receive the parameters using this program number and the schematic. Also, there are ways to follow information and confirm the fitting of schematic by identifying the model and make year separately, and this can be done following the VIN identification steps. So in such case we can proceed. So basically, identification of vehicle can be made according to the VIN number. Any standard vehicle that database search platforms can provide you information just on manufacturer and model. However, usually details such as make year and options will have a cost. So as an alternative, if you already determined the VIN number, you can also refer to the presented table to identify the manufacturer year by your end. So the VIN number, of course, consists of 17 symbols. So the 10th symbol presents the manufacturer year. Basically, according to the symbol provided in the 10th place, you can determine the make year, but also please take into consideration that there are repeated characters in the table, and to further fully confirm the make year, you have to make sure to follow the position 7 of the VIN number. So if the position 7 of the VIN number is numerical, it refers to manufacture year between 1980 and 2009. If the position 7 is alphabetical character, it means that the manufacture year should be between 2010 and 2039. Let's proceed further on. So after you fully identify the vehicle model and the required semantics, we also need to make sure that our unit is running the latest firmware and software versions suitable for that specific program number. So we have a remote update functionality in our PhotoWeb platform. So basically this screen will be used to describe the further steps. So our PhotoWeb solution allows to keep up with always extending supported vehicle list when new vehicles are added. To begin with the CAN unit software update, so our Teltonika tracker must be running current recommended FMB 140 firmware version. So specified here is 03.25.16 Rev 410. This is a base version of firmware used for FMB 140. Also, other firmware versions based on this branch can be used. So any newer versions that are already released. Once the suitable firmware version is assigned in the device, when the device is updated to that specific version, you can see that ability to update the CAN adapter. So basically you will see a logo of the CAN adapter, which means you can proceed with the update. So simply to apply update, you must create a task. So this can be applied for all of the units, specific units or single unit. And when the number of units are selected, you can choose the next step is to create the task. The create task tool allows to choose a number of options for the unit. However, to proceed with CAN update task, you have to, of course, choose the update CAN adapter task type. So afterwards, when you choose this type, create the task is placed into the platform and the platform awaits for unit to connect. So basically, unit will connect after PhotoWeb connection period or after connection is initiated by command web connect. Afterwards, it connects to the platform, it will update, and once task is completed, you can follow up and double check the information visible in the platform. So to monitor the device status, you can overview the device information. So basically, one of the vital points presented is type. So PhotoWeb will be able to provide you basic information of what type of unit you're running. In FMB 140, you will have two options. So basically 140 LV CAN or all CAN option. Also in the device information, you will be able to identify currently set program number in the unit. Additionally, very important parameter is software date. So you will also be able to identify it there. Of course, additionally, you can always inspect the changes made to the device in the changes tab. Let's move on to the configuration of the device. So it is possible to pre-configure device before installing or just to by creating a configuration file, or you can simply configure the device on the spot by connecting via USB cable using our configuration software. So basically, first of the important steps is to, of course, specify and change the program number to the matching one here. So you can do this via configurator as described. Also, you can use our special command lv-can set prog. This allows you to update the program number remotely using SMS or TCP commands. Also, you must make sure to enable required parameters. So by default, the CAN adapter parameters will be set to priority none. This means that they will not be included in the records and will not be sent to the server. If you want to enable parameters which are readable to be sent, of course, you have to select low, high, or panic priority. So, of course, this is done via configuration, or of course, you can use the SMS or GPS commands to execute this remotely. So, for this occasion and for this specific situation, you would have to use a set param command. So, for all of the specific commands, I highly suggest you to double check our information in Wikipedia. Additionally, when talking about configuration in scenarios where more convenient and advanced integration method is required, it is possible to develop Bluetooth applications according to our Bluetooth protocols and apply the required changes or read the data from the unit using mobile applications. I believe the part of the configuration is fully covered. Let's move on to the commands that are specific to our CAN solution. So let's have just a basic overview. So we have a lv-can set prog command, which has been previously described. This is used for all type of devices to configure the preferred program number. lv-can close all doors is used specifically for all CAN control devices to close the doors. lv-can fault codes is a specific command to use with the DTC units. We also have the lv-can block engine only for CAN control plus IMO units. And there are other commands that are, of course, listed in our Wikipedia, so you can make sure to check information there and proceed with the application of the commands. I believe we can move on with the tips in regards of the installation process. So I believe one of the important steps is simply to identify the schematics correctly and have a good preparation. So usually information such as a number of connections will be specified, and you must make sure that you determine the exact amount of connections required, since if, for example, you will be connecting using eCAN contactless adapters, you may have to take 2 into the installation point. Additionally, connection location. So, of course, in most scenarios, there will be a single connection location, but you may find instances where in the schematics there are several ones. So I will further explain later on what to do in this situation. You will also acquire information on connector. And additionally, I expect that we will shortly walk through the features of our eCAN adapter. So for the first step in regards to the installation, so in case you see the several connection locations. So you may encounter situation where several CAN lines are present. So basically it is required to connect only a single CAN1 line as specified per schematics. The location of connection should be chosen according to your preference. Connection to either of the specified CAN locations will provide you identical data. For some vehicles, only one of the specified locations may be present due to differences in vehicle options, which results in different wiring harness. Additional step in regards of installation that should be noted, this fully relates to CAN control units. So CAN control units are used for blinker control, central lock control, and majority of the supported vehicles will have this option available via direct connection to CAN line and control message sending to CAN bus. However, for specific models, such option may not be available. So in case in this, you will be notified in the supported vehicle list with the light blue marker. So basically a square identifying that alternative signal wire should be used. In the schematics, you will have a definition of where to find this alternative wire. And also it will be specified in the schematics that you must connect this wire to the CAN control unit. Of course, in case it is specified that you do not connect the wire, no action should be taken. Let's move on further in regards of connectors. So due to the fact that there are some models manufactured in different countries or some vehicles that may use not matching wiring harness due to options it has, wiring colors may not be exactly identical as shown in the connection scheme. As presented in the picture, we usually define the wire colors and the connector colors for each CAN line and for each wire. These initial points must be used as reference. So in the provided example, you see the connectors and the pin locations. However, if you are able to determine the same twisted wires with different colors, you can ignore the colors and connect just according to the pin number. Also, there may be occurrences where the connector type may be different or the color may be different. However, if you are able to see a twisted pair, this will most likely identify the connection of CAN line. In case you're not sure, of course, you can contact our support team or try connection using our eCAN contactless adapter. So I believe we can move on to the eCAN adapter. So basically, when direct connection requires cutting the wires, and this may not be acceptable as an end solution. So as an alternative, we have the eCAN adapter, basically which allows you to read the signals through the insulation of CAN wires. Simply, this procedure to connection is simple. So basically you have CAN L and H wires inserted into our casing in the specific locations. You must enclose the casing fully and firmly. And basically this covers all the procedure. So as you see, it is a really simple way to perform installation. However, there is a single disadvantage of this type of connection. So basically, when using contactless adapters of any kind, it is not possible to read specific parameters or send request messages to CAN bus. Therefore, application with units such as CAN control, it is not convenient because you will not be able to use unlock or lock features. Just for example, I will further identify how the features that may not be available with eCAN are defined in our supported list. So you can check this there. So basically, parameters that are not readable or functions which are not usable with our contactless adapters will be marked with orange. This means that direct connection is a requirement if you want these functions to be available. Also, I think important step is always to make sure and double check the integrity of eCAN connection. So here is an example of bad connection. the bad clipping, the casing is not fully closed. It means that wires may move while the vehicle is moving. This will count to times where some data or all of the data will be missing. And therefore you must make sure that the ECAN is always firmly clipped as provided per instructions. So let's move on to the procedures for adding not yet supported vehicles. Basically, even though we are always sending our supported vehicle list, and it already covers vast majority of international vehicle markets, there is a specific number of newer or more rare vehicles that have not yet underwent reverse engineering tests by our team. To proceed with such projects in shorter time periods, we offer several solutions. So basically, first one would be testing with similar vehicle model semantics. Another option is providing us details to perform remote tasks. And the last, and I believe the most easiest and convenient, is using AutoScan feature. So let's begin with the first option. Some of the vehicle models are based on a single platform and may have identical connection, wiring, or program number. So as defined here, we have an example of Jetta made from 2005. It is based on the same platform as Passat CC from 2009. Basically, the wiring harness is and the program number used is identical, and also the wiring harness is also identical. There are a lot of situations where you can find a specific model that is already supported, which is older, and use it as a reference when connecting to a newer vehicle. For faster identification of similar models, of course, it is recommended to do some sorts of research and find what type of vehicle model it may be based on. Remote ways of assistance for new projects. So when there is a demand for a new vehicle, we are able to request our team to research for it and to be tested, or alternatively to specify at least the location of CAN bus. So in case of such request, we usually request information for photos of the vehicle. So the connectors that are found there, usually in the OBD port location. Also useful photos of the can be such as interior electronics and multimedia systems, and the photos of vehicle model itself. So basically this information is very useful for us to define and conclude what exact model we have to check. In case we are not able to check, we can at least suggest the possible location for CAN line. Additional way for remote tasks is when the end user or the client has information and the protocols of the vehicle. So files such as .dbc files or description of each parameter may be used for evaluation of what data can be provided. We can, after evaluation, we can proceed with the development and preparation for new software and program number remotely. Just an example, client MV Agusta has full access to their motorcycle protocols, and we have received a request to make software and program number according to their files provided and the protocols included, and basically during development process we were able to complete all the tasks and prepare all the software required remotely without having a direct access to this type of motorcycles. So it could be useful for some specific solutions where you have protocols of the vehicle or motorcycle or any other transport you want to implement. Let's move on to last way to proceed on adding new supported vehicle. So auto scan function, I believe, is most easiest and convenient. However, a specific feature for FMB 140 units. So basically, FMB 140 units can scan information incoming from CAN bus and determine parameters by generating several program numbers that will be later on used for data read. So to proceed on auto scan functions, we firstly would have to update the device to recommended firmware version. And when connecting, of course, we should find the connection. So connection for scanning is usually done via the OBD port, so diagnostic connector. We also have, of course, schematics where the connection should be made. So basically, FMB 140 CAN1L and CAN1H wires have to be connected to OBD connectors pin 14 and pin 6. Then the connection, that's all for the connection in regards of the OBD port. There are basically two ways to execute auto scan once the connection is done. So auto scan on init feature means that auto scan will be completed once device reaches specific conditions. So if device has pre-configured program numbers specified here, if the unit's ignition source is digital input 1 or power voltage, and if ignition is of course on. So basically after these steps, the unit starts the auto scan procedure. It will scan for available numbers with a timeout of 50 seconds. Auto scan feature will retry for 3 times. After that, the auto scan will be cancelled. If auto scan on init is successful, it will take and save the first program number received and set it to internal CAN chip and device configuration. Thus, device will continue to work with that specific program number. The rest of the program numbers will be accessible via command lvcan prog list. Another way to proceed with auto scan is simply connecting to the configurator. So after connection is done successfully, you can launch the configurator, navigate to the CAN adapter tab. Of course, before clicking the scan button, make sure that the ignition is on and the ignition source is configured to digital input 1 or power voltage. After initiating the scan with the scan button, the configurator will wait up to 60 seconds to send up to 9 program numbers. If timeout is reached and the scan is unsuccessful, it will display an error. If the unit is unable to detect CAN bus connection, the unit will also return an error. In case of successful scan, a list of compatible program numbers will be displayed. So, as mentioned before, first and best considered by unit, the best program number will be saved in the flash and the configuration. You will be able to check that data live if connected via USB to the unit. The parameters that are readable will be marked in green. You can also scroll up and check the data received with different program numbers that were scanned during this procedure. Some guidance on how to proceed if scanning via connection to OBD is unsuccessful. So if it goes unsuccessful, you can try connecting CAN1L and CAN1H wires directly to vehicle CAN bus using our eCAN contactless reader. If required parameters are available only with different scanned program numbers, and in such case there are scenarios where some specific program number has a batch of parameters which are required, another has the other parameters with it, so we can simply do a software changes, and for it to be completed, it would be required that you provide us list of program numbers that you have tested, specify the parameters that were read with each specific program number. Also, of course, the vehicle information such as model and year. Afterwards, as mentioned, the software changes can be developed to reach the final complete solution, basically compiling the provided information and creating a single program number that can return all of the parameters. I believe we can move on to the last section of common mistakes and debugging. So here we will cover shortly what are possible software and configuration mistakes, and also how to check. Further, we can double check the installation related mistakes. So to proceed, usually and most frequently, users do not notice or pay attention to the defined software date of vehicle semantics. In such scenario, the model may not be yet supported by older software version, so no CAN data will be read, even if connection and program number are configured correctly. Or another alternative scenario is that the specific program number was not added to the older software version, so it is not possible to end. So basically, this is response of LVCAN get info. Additionally, PhotoWeb will also provide you information on software date. So a point to be checked is simply to match if the current software data used is newer or at least the exact as provided in the semantics here and here. Alternative and common issue is that CAN adapter may be not correctly connected to the tracker. So CAN adapters such as AllCAN, CAN Control, LVCAN 200 must be connected to our tracker via serial port, so using mini USB. For FMB6 and older units, for our newer units such as FMB1 series, input 5 and 6 must be used. Together with this, it is also, of course, important to connect the power source to the CAN adapter and, of course, the ground. If units are not powered or correctly connected to our trackers, command LVCAN get info will return response with zeros. This means that no information is coming from the separate adapter. The mistakes in regards of connection are usually related to mixing wires. So make sure that CAN-H and CAN-L wires are not mixed. Make sure that you follow up the pinout. Also, make sure that you connect to correct CAN bus. It is very important to always follow throughout the semantics and do the installations as provided in the semantics. Sometimes in some occurrences, quick splice and fast connectors are not a fitting solution, if the wires are very thin. So basically, in such scenario, it would either require a direct connection, and it is recommended to solder the wires. Additionally, in all of those scenarios can be checked, and if you want to confirm validity of your connection, you can monitor the status that is sent in our records. So we have a specific element security flags, so you can confirm the connection by monitoring the value sent by it. To do this, basically you will receive the element and a hexadecimal value with it. Afterwards, you convert it to the binary and parse from right to left. There are possible values that will be returned, so you can follow our information in wiki on security state flags. You can have the 3 statuses with security flags. So basically, if you determine that you have 0, 1 in decimal, which means that CAN 1 is connected and currently no data is received, this usually refers that the required CAN line is connected correctly, but the data is not incoming. This may occur when there is no ignition or the CAN bus is in sleep mode. Also, you can have a response of 0, 2 in decimal, which would mean that CAN 2 is not connected and requires connection. This means that the unit has checked the requirement of connection for that specific CAN line according to the program number. However, no data is received. And lastly, you will have a confirmation if CAN 1 is connected and currently data is received when the required CAN line is connected correctly, and you should be able to receive the sent data by the unit. So just as main features were covered and the information was presented, I can move on to the advantages of our solution. So I believe the main advantage we have is now the auto-scan feature, which helps to create integration with newest models. Also, of course, we have detailed schematics, which we update daily, and this helps to guide the integrators. And of course, we have options to configure and update the device remotely in case the installation is already made and you have to make improvements.